All right, guys. I won't belabor the point. I should have the test graded tomorrow for you. If you didn't do well on it, we'll figure something out for this first one, I think, to do it. But if you didn't do well on it, maybe it'll be a little of a wake-up call about what needs to happen for the next time. We'll see it. I think it does, to some extent, the stuff builds on each other. So what you needed to know for this, you'll need to know for the next stuff and the next stuff and the next stuff, right? It'll just be in a different form. But we'll see. We'll see how you did. I'll grade them tonight. Get a big cup of coffee and crank it out. Grading is probably, the teachers hate grading. Most teachers hate grading, so I am no different in that regard. OK, so here's what we're going to do tonight. You guys are going to hate me today. You're going to hate me after this. We are going to work on a ton of word problems. OK, so if you guys hated the word problems on here, we're going to see a ton more word problems tonight. I mentioned this to somebody earlier. Word problems are like real life is word problems, right? You don't see numbers just kind of floating out in the middle of nowhere, right? If you go and you're watching on TV and somebody says this couch is 20% off and is however much dollars or whatever, then if you want to find out how much it should have been or whatever, that's a word problem, right? It's just that's set out. It's just kind of detailed out. So what we're going to do tonight is I'm going to go through a few word problems, and I'm not going to talk to you for very long tonight. It's going to be kind of like last week, where I'm going to do a bunch of word problems, and then I got a sheet that you guys can all work on, and at your own pace, work on it. But I'll show you some tricks, I think, that will hopefully help you out. OK? So this is section 6.3 in the book, and it's called Applications of Linear Equations, which really means word problems. OK? Applications means word problems in this case. So applications equals word problems. And by the way, equals, if you see something that says, at what point will something be the same as something else, you better stick an equal sign in there somewhere, because that means this side is equal to this side, meaning they're the same. Right? So that's what we're going to, that's the kind of the first thing. A lot of this is about vocabulary, and not vocabulary that's hard. Vocabulary is like figuring out how to get the words into numbers, or the words into the equation, really, is what it comes out to. In your book, if you look at table, you don't have to do it now, but table 6.2 is really important as far as explaining what the words how the words translate into mathematics, how the English translates into mathematics. OK? So for instance, if I said the sum of a number plus 3. OK? Here's how I think of this. I always do the following. I pick some letter for our variable, and I just say that's whatever I see number, I'm going to say make it x, or make it y, or make it z, whatever letter you want. I'm going to say the sum of a number, and I'm going to say x for that number. And then anytime you see things like plus, that's easy. Plus, and then 3. Right? So if you see the sum of a number plus 3, you're going to say x plus 3. OK? That isn't that hard. It's hard when you see lots of other words in there and you don't pick out the right ones. Always put just a little x or y or whatever over the number. OK? How about the difference between a number and, let's say, 6. The difference between a number and 6. There you go. I put an x above the number, right? And then the difference means minus, OK? And you're going to say the difference between a number and 6. The minus goes where the and is in this case. Sometimes people flip it around, but it's not. You got to say x minus 6. And isn't whatever that equals the difference between x and 6, right? So if x happened to be 20, well, the difference between x and 6 is 14, because 20 minus 6 equals 14. So that's how you think about problems like that. Okay? If I said 3/5 of a lump of something, a lump of whatever, a lump of rock, right? 3/5 of that, you say 3/5, because that's a fraction. And then this is our variable here, x, 3/5 x. 3/5 of a lump is 3/5 of whatever that lump is, in this case, x. Okay? These are the things that you just hear. If we're going to do enough of these that you'll start getting them into your brain. If you really are having trouble with them, I guess it's a matter of memorizing some of those terms and then just practicing it some more. If we can figure out where you're running into trouble, then we'll try to dig in and do it. I think we can figure it out. Okay, I don't have any worries. Lots of people have learned this stuff, and lots of people have had trouble with it. But I think we can learn it. Okay. All right. By the way, the colors out here, if you're on an army base, colors is about twice as fast.
Oh, way quicker.
Way quicker. I don't understand why they do it so slow here.
There's 2 parts to it.
There's 2 parts to it? Which, well, we play the slow part?
Yes.
Really?
The second part that they play there, they play that on army base when they play quicker. But the preamble,
The preamble's
the
slow?
boom from the cannon,
Uh-huh.
and retreat.
I think what happened was some Navy guy was like, I don't know what reveille sound, or I don't know what color sounds like, and just looked it up on like YouTube or something, and that's where it was. So I Googled it, yeah.
The mixed version?
The what? The mixed version, yeah. That's hilarious. All right, okay, you ready? Let's try this. The difference between, and I'm going to write this out, so some people hear better and some people listen or read better, but the difference between the product of 6 and a number and -2 times the number. I'm going to write this out. The difference, you should already be thinking subtraction, right? Between the product of 6 and a number. I know what you're thinking when I say that, right? A number. And -2 times the number. Times the number. If you say a number and the number, it's going to be the same variable, right? Try this one for a sec while I'm erasing, and I'll put it up there. But give that a shot. See if you can figure out what that would translate into in terms of math. If you can't, it's all right. Start circling key things. There's a lot in this one. Y equals. Is there any equals in there? Good idea, but is there any equals in there? Close. You're close on that one. OK, so let's just write a couple things on here first. What am I going to write for difference? It's going to be a minus. Subtraction. The product is going to be what? Multiplication. We know 6. What am I going to write for a number? X. I'm going to write the same thing for this one, too. The number is also x, because it's the same number in this case. And -2, I'm going to write just -2. And then times is going to be x again, right? OK. The difference between the product of 6 and a number. What are we going to write for that? That's where I would start on this. Forget about the difference part right now. You're going to do what?
6x.
6x. OK. Everybody get that part? The product of 6 and a number is 6 times that number, 6x. Good. The difference between that is the part where we're going to put a minus. I saw most of you guys that I looked on had that in there. All right, and negative 2 times the number. Well, what's negative 2 times the number? Negative 2x. OK? So that's what you want to write. There's no equals in there. Nothing's saying anything about being equals. OK? Later we'll get into that part. But 6 minus negative 2x, which is really the same as saying 6x plus 2x. But that's after you do some translating again. And that would be silly to write it, kind of silly to write it this way, but that's what it ends up being. Sometimes you'll see it with parentheses there too, which is fine. Okay. All right. Questions on that one? All right, let's try another one. This is I'm gonna have a sore wrist after writing all this down. Okay. All right. The average yearly salary. The average yearly salary, okay, of a man with, or woman, with some college. Remember this one? By the way, it's probably not true. Unfortunately, in the Navy we're doing pretty well, but otherwise we're not quite the same salaries for men and women yet in the world, which is kind of too bad. The average yearly salary of a man with some college exceeds that of a male high school graduate. This is like the stay in college kids speech, right? High school graduate by $6,000. OK. We're like a third of the way down to the problem. OK? A man with a bachelor's degree, which all you guys are working on. Most of you guys. Some of you guys are working on associates, right? Or more earns $41,000 more than a man with some college. OK. Now, let's see. We have a man with some college sees that a male high school graduate, a man with a bachelor's degree or more earns $41,000 more than a man with some college. OK. Combined, these three men earn $179,000. OK. Find the average yearly salary of men with each of these education levels. With these education levels. I'll abbreviate a little bit. OK, the education levels. OK, that is a monster word problem, right? Here's how I would attack it. OK, I would say, what do we know the least about? High school kid we know exceeds that of a male high school kid by $6,000. OK, so in this case, I would say that's the one you're going to want to give a variable to. You can do this a number of ways. When I looked at this the first time, I said, let's have 3 different variables for college and high school and whatever. And we could do that. OK, so I mean, we could do that. So we could say a male high school graduate, and you could use, let's say, H for that. OK, and a man with some college, let's say, we'll just call that college, C. And the other one is a bachelor's degree. So let's say graduate. How's that say? G. You could do it this way. This is the way I started doing it, by having 3 different things. Probably an easier way to do it is just to do it all at once, combining the terms as we go along. Okay? So if we know that H equals the average salary for a high school grad, okay, for a high school grad, let's try to plug in all the different parts we have for this. Okay? So the average, let's see. What do we know about here? This high school grad. There's a $6,000 in here, right? So the man with some college exceeds that, which is what? Exceeds is going to be what? More or less? Exceeds, I heard both, more or less. Exceeds is actually going to be more, right? Because it exceeds it, right? So you're going to say something like 6,000 plus the high school graduate. Which one is this? That's the college graduate, right? Okay? This is not a divided by. I'm just kind of, it's a little, this guy. Okay. All right. 6,000 plus H. And by the way, at the end, we're going to want a number equal to 179,000. OK. So that's that one. Now, a man with a bachelor's degree earns 41,000 more than a man with some college. This was the college one. So what if we did this? Plus 6,000 plus H plus what? 41,000. And which guy is this? This guy's the graduate. OK? That's G, yeah, for the graduate. OK? I'm sorry, you can't really see that. But that's G. This is the college guy, still in college, still doing college. This is the graduate. Which one did we actually not write down yet for the original? The high school guy, which is just H. So I'm going to put that over here. H plus that. So now we have the high school graduate plus the college guy plus the graduate equals how much? 179,000. OK? So I'm going to rewrite this up here in big words so we can all see it. So I'm going to erase just the top of this. OK? I'm going to erase just the top of that there. OK? And it's going to be H plus 6,000 plus H plus 6,000 plus H plus 41,000 equals 179,000. Now, do you think we could solve that for H? Right? Let's do it. OK? How many H's do we have on this side? 1, 2, 3. 3H plus, well, 6,000 plus 6,000 is 12,000 plus 41,000. How much is it? 53,000? 53,000 equals 179,000. OK? Now we're going to try to do what? Get the 53,000 on the other side. So we subtract both sides. I'm going to erase a little bit more here. Actually, I guess I'll erase this one because we'll come back to it. OK? 179,000. OK. So we're going to subtract 53,000 from both sides. 53,000 from there. We're left with 3 times the high school student equals 9 minus 3 is 6. 126,000. Yeah, all right. Then we divide both sides by 3 to get rid of the 3 for that. That's going to go away, and we're going to get that. What did you say 126,000 is? 42. 42,000 equals the high school grad. It's not bad, actually. I'm going to high school. Anyway, 42,000, OK, high school grad. now we got to plug in the other ones. Now I erased some of this, but let's see. This person said the average salary of a man with some college exceeds that of the graduate by 6,000. So if that's the high school, then what's the college guy? 48,000, because we're going to add 6,000. And then, and then the graduate is going to be 6,000 plus 41,000, which we already have, plus another 41,000. No, yeah, that's it, for another 41,000. So they're going to have the graduate equals, $89,000 per year. And if you add those three numbers up, you should get the total of 179,000. With word problems, you can almost always check your answer. Okay? And that should do it. Now, that was a pretty crazy one, but it was, you could see that we had to do it step by step by step. You could, the original way I did it was I had H plus C plus G. H plus C plus G equals 179,000, right? And then I just plugged in each one for C and G separately. You could do it that way too. You could say this one's going to be 6,000 plus H. This one's going to be 6,000 plus H plus 41,000. So you can do it step by step that way. Okay? But that was kind of a, like I said, kind of a monster problem. Any questions on those ones? That one rather? Okay. We're going to get to lots of others where in the practice. Okay. Who's still writing down the answers to these? Yeah, I'll wait. The next one we're going to do is where we're going to try to choose between like plan A and plan B. For instance, if you have a cell phone plan and you go to like AT&T and they're like, well, we'll give you for $70 a month plus for 300 minutes plus 5 cents a minute for all extra minutes. And the other plan says, oh, it's only going to cost $20 a month, but it's going to be 15 cents a minute for all the extra minutes. If you know how many minutes you're going to spend, you can figure out what that break-even point is and which plan you should probably get. Right? You don't always go for the one that saves you money up front. Okay? So let's do one like that. Okay. All right. The one I'm going to do is not like any cell phone plan I've ever had. Okay, plan A. Okay, plan A says it's $20 a month, $20 per month, plus 5 cents a minute, 5 cents per minute. Okay, and we're going to say immediately. So let's say there's no like other minutes involved. Let's say you automatically have to pay $20 a month, and every minute you do is 5 cents a minute. It's a little easier than the other way around, but that's OK. And then plan B is only $5 per month plus 10 cents a minute. Okay. First things first. What am I going to have to? What's wrong with the units here? $20 and 5 cents. They're different units. You can't use. You're not going to end up using 5 and 20 because they're different type. They're different amounts. And if you want to watch something, or if you want to listen to something really funny, look up Verizon 2 cents per kilobyte. No, 0.02 cents per kilobyte on like YouTube or Google or whatever. Some guy. It's kind of a long story, but some guy had a cell phone plan. He was going to like Canada or something, and he called up his cell phone company and said, "How much is it going to cost me for to use my phone data, the like internet in Canada?" And they said, "Oh, it's going to be 0.0. I think he said 0.02 cents per kilobyte." Right? Well, 0.02 cents is actually what? 0.0002 dollars. Because there's 100 cents in a dollar. Dollars per per kilobyte, which is actually pretty good. You can do data for a long time at that rate. But then when he got his bill, they charged him $0.02 per kilobyte. And he called up and complained, and he's got all the tapes of all the conversations. They didn't believe him. They're like, no, it's the same. Dollars and cents, it's the same. And because his bill was like, I don't know, $700 or something, and it should have been $7, right? So they totally got it wrong. But he's got all these things of like arguing with these people, going, no, you don't understand. There's a difference between. Do you believe there's a difference between $1 and 1 cent? Yes. Do you believe there's a difference between $0.02 and 0.02 cents? No. And they're like, no. But anyway, so we got to convert some units here. OK? Got to convert some units. $20 a month plus 5 cents. OK, what is 5 cents in dollars? Let's do it in dollars. It's 1/20th. Or how about this? Instead of saying, well, you could say this. 1 cent, I'll do the little cent symbol, OK, equals $0.001. 0.01. Sorry, I did the same thing with a 0.02. I could be a Verizon operator. OK. Anyway, $0.01 because that's 1 divided by 100, right? $0.01. OK. So 5 cents is going to be what? Equals sorry, now I got you all confused. It's just 0.05. Yeah, $0.05. OK. Same thing here. 10 cents a minute is $0.1. OK, because it's twice as much. OK, divide 10 by 100, you get 0.1. Okay. Make sense? OK, now we've got this. All right, so when you're choosing between plan A and plan B, the question is, what number of minutes, I probably shouldn't write in orange. Can you guys see orange? Is that all right? All right, well, anyway, what number of minutes results in the bill from both plans being the same? If you see the same, what are you going to put in there? An equal sign. OK? You're going to put an equal sign in there. OK. So this one isn't, I don't think this one's really too bad once you realize that you're just going to put an equal sign in there. OK? $20 a month plus 5 cents per minute. What am I going to write down? 20 plus 0.05. OK? What? Not quite. We're listed times something, right? Because this whole per minute thing, OK, let's call it, I don't know, the number of minutes. Because that's what we're looking for. What number of minutes, right? You might use x if you want. I'm going to use m because it stands for minutes, right? The number of minutes. 20 plus 0.05 times m, or x if you wanted to do x. OK. Now we've got the equal sign. And then what am I going to put in there? 5 plus 0.1 times the number of minutes. Don't forget that on both sides of that case. Okay? Then you have to solve this. And what are we solving for? Solving for m. This is why all the stuff that we did last week is kind of important, because now you're going to actually apply it all. OK. What's the first?
Oh, okay.
0.1 is 10 cents, yeah. Oh, yeah, 0.1. I always put the 0 in there just to make sure you know where the decimal point is. OK, so what can I do to start solving this? Yeah, let's subtract 0.05 from both sides. Or you want to subtract 5. You want to subtract this 5? OK, either way. Minus 5 here, minus 5 here. And we're going to get 15 plus 0.05 m equals 0.1 m. OK. I'm going to move it up to here now. OK. Move it up to here. All right. 15. Now what are we going to do? Yeah, let's subtract the 0.05 m from both sides. Minus 0.05 m minus 0.05 m. Well, 15 plus 0.5 m minus 0.5 m gives you 15 equals, on the other side, 0.1 minus 0.05? 0.05. You can do that on your calculator to prove it. Now what are we going to do? We got to get rid of the 0.05 over here, so we divide by 0.05 on this side, divide by 0.05 on this side, and we get what equals m, because these are going to cancel right out. 15 divided by 0.05. 300 equals the number of minutes. So if you talk to your girlfriend for more than 300 minutes a month, you'd probably want to go with one plan over the other, because that's the break-even point, right? And that's where you got to think about it. So I erased what the two are, but which one's actually going to give you, which one's going to be more? If you talk for less than 300 minutes, if you talk for less than 300 minutes, which one's going to be more? The one where you've got 10 cents a minute and $5, or the other one? What's that? This one's going to cost you more. Yeah, and you can test it. You can test it with like 301 minutes. OK, because if you know the break-even point, you can actually do it. Or we could do, I don't know, let's make it easy. Let's do 1,000 minutes and just see which one works out. OK, the $20 plan, 20 plus 0.005, sorry, 0.05, 0.05 times 1,000 equals, let's see, 1, 2, 3. So it's going to be 50 plus $70. OK, there's the one plan. And the other plan is 5 plus 0.01 times, there I go again, 0.1 times 1,000. OK, so that's going to be 100. So it's going to be $105. So yeah, if you are talking for more than 300 minutes, definitely go with the plan that costs you a little more up front, because in the long run you win. And this is how we know. And if you did 301, this one would still be more expensive. Or sorry, less expensive. If it was 299, this one would be less expensive. OK, and it's the break-even point is 300. Okay? Later on, we might have to graph these things. No, don't worry. Don't worry. It'll be all right. It'll be all right. Trust me. OK. All right. So those are a couple of the big ones. We may have to do a couple other ones too, where we talk about trying to solve just for variables inside of an equation. OK? So for instance, if you have anybody remember what if this is the length of a box and this is the width of a box, what's the perimeter of the box? What is it? Yeah, you're going to add this one with 1. The perimeter is the outside amount, right? Width plus length plus another width plus another length. So you got 2 width plus 2 length equals the perimeter. OK, what are we solved for already? What's already solved for in this? The perimeter is, right? If you have the length, you have the width, you have the perimeter. But what if I gave you the perimeter, and I gave you how long it was, and I wanted to know how wide it could be? Like, let's say you buy a piece of land, right? And you buy a bunch of fence, and you find out that you have X amount of fence, like you have so many feet of fence, and you know how long your property is, and you want to cover a whole side. Well, this will be able to tell you how wide it's going to end up being, let's say. Not that you'd probably ever do exactly that calculation, but let's say we wanted to solve for W. We can do that in here. You have to leave all the other variables in there. You're not going to get just one variable. Just pretend all the other variables are numbers if you want. OK? If I'm going to solve for W, what's the first thing I might do? What is it? Yeah, we're going to end up, I'm going to give you the length and give you the perimeter. And I want to know what W is. Subtract what? Subtract 2L? Sure. Subtract 2L equals P. Well, oops, sorry, minus 2L over both sides. Minus 2L. Yep. And you can do this, right? 2L minus 2L is no L. So you're left with 2 times W equals P minus 2L is P minus 2L. You can't do anything with that, so you leave it. Now what do we do to get rid of the W, to get the W by itself? Divide both sides by 2. Don't forget to divide the whole thing by 2 over there. You could either do each one individually or the whole thing. That's going to cancel out. You're going to be left with the width equals the perimeter minus 2 times the length divided by 2. Okay? And that's how you'd end up figuring for the width if you knew the length and the perimeter. Okay, those kind of problems are the other ones that we'll look at. Those ones aren't so much word problems as rearranging equations problems. Okay? All right, any questions on that? All right, here's what I want to do. I'm done with talking at you tonight. I'm going to give you this sheet which has a ton of word problems on it. You don't have to do all of them tonight. Okay, it's got 28 ones on it. Well, some of them are these solving ones. Okay, work on them. Take at least one more break if you want. And then we'll be done at 8:15. And you can leave whenever you feel comfortable with this stuff. Okay?